All right, let's dive right into this. Welcome, everyone, to today's explainer. If you're learning to program, you've probably already figured out that code is kind of useless if it can't make its own decisions, right? Today, we're going to demystify conditional logic in Java. And to do that, we aren't just going to stare at boring syntax. We're going to use simple, real-world analogies to make Java's decision-making crystal clear. By the end of this, you're going to see that thinking like a computer really isn't all that different from how you navigate your daily life. Here's our roadmap for today. We're going to cover decisions in life and code, the if-else foundation, multiple choices, reversing logic, the switch statement, and we'll wrap it all up with controlling flow. Let's get to it. So, starting with Section 1, Decisions in Life and Code. We're taking this from human logic straight to computer logic. Think about these everyday health protocols we all got so used to. You evaluate situations like this literally all the time. You think to yourself, okay, if I'm going to be near a bunch of people, I'll put on a mask. Or if I'm out in a public space, I'll keep a 2-meter distance. You're constantly checking a condition, and if it's true, you take an action. Well, guess what? A computer program operates the exact same way. It desperately needs conditions to navigate data and actually do the right stuff. Which brings us to the actual Java syntax. What you're looking at right here is the direct translation of that human thought process into code. It's beautiful, really. We just write the word if, followed by our condition wrapped in parentheses. If that condition turns out to be true, bam, the program steps inside those curling braces and runs the code. If it's false, it just skips it entirely. It's wonderfully simple. Moving right along to Section 2, the if-else foundation, where we actually build these conditions. Now, the thing is, computers aren't great at nuance. They need exact mathematical comparisons to figure out if something is true or false. So here are your 6 essential comparison operators in Java. You've got less than, greater than, the exclamation point equals, which is just a fancy way of saying not equal to, the double equals for exactly equal to, and of course, your less than or greater than or equal to symbols. These are basically your building blocks. You'll use these all the time to ask the computer a definitive yes or no question. Let's actually see one of those in action. Here we've got an integer variable, x, and we've set it to the number 7. Then we hit our if statement. The program asks itself, is x less than 42? Well, since 7 is obviously less than 42, this condition evaluates to true. So the computer seamlessly steps into that block of code inside the curly braces and executes whatever instructions we've put in there. All right, Section 3, multiple choices using else if. Because let's be real, in the real world, a simple yes or no often just doesn't cut it. We usually have multiple possible scenarios. And look at how elegantly Java handles this with the else if structure. We have an age variable here, set to 25. The program reads this top down. First up, is age less than or equal to 0? Nope, 25 is way bigger, so it skips it. Next line, else if age is less than or equal to 16? Still no, so it skips that too. Next up, else if age is less than 100? Ding, ding, ding. 25 is indeed less than 100. It found its true condition. And because that specific condition was met, the program jumps into that block and prints welcome to the console. Now, here is the absolute beauty of this structure. Once it finds that true condition, it runs it, and then it completely ignores the rest of the entire block. It doesn't even bother looking at that final else statement. It made its decision, it did its job, and it moved on. Which leads us to Section 4. Reversing logic with not. Get ready for the exclamation point operator. So in Java, the exclamation point is the logical not operator, and its entire job in life is just to be a contrarian. It takes the logical state of whatever is right next to it and flips it completely upside down. True becomes false, and false becomes true. I know it sounds a little counterintuitive at first, but trust me, it is incredibly useful for streamlining your code. Check out this snippet to see what I mean. We've got our age set to 25 again. Inside the if statement, we look at those inner parentheses first. Is age greater than 18? Yeah, 25 is bigger than 18, so that part is true. But wait, we wrapped that whole thing in our logical not operator. So the not operator grabs that true and violently flips it to false. Because the final evaluated condition is now false, the program will absolutely not print too young. It basically acts like a bouncer, reversing the logic to check if someone happens to be under the age limit. All right, big paradigm shift here. Section 5, the switch statement, for when you have multiple execution paths. Okay, I want you to imagine writing a program that takes a number 1 through 12 and prints out the corresponding month. If you use that else if chain we just talked about, you'd be writing else if 12 separate times. Honestly, it would be a sprawling, unreadable nightmare of code. There just has to be a better way, right? And luckily, there is. Enter the switch statement. This control flow statement is designed exactly for this type of scenario. It gives you a super clean, elegant way to handle a whole bunch of possible execution paths based on a single variable. And it works beautifully with whole numbers, characters, and even text strings. The real trick here is just knowing which tool to pull from your toolbox. You're going to want to use an if-then-else statement when you're testing ranges, like we did earlier when we checked if an age was anywhere less than 100. But you use a switch statement when you are hunting for a single exact match. Like, are you exactly the number 8? Are you exactly the word August? If so, take this specific path. I mean, look at how remarkably clean this syntax is. We pass our integer variable, month, directly into the switch parentheses. Then we literally just list out our cases. The code scans for case 8, finds that exact match, and prints August. It is so much easier to read and maintain than a giant clunky chain of if statements. Now here's a quick pro tip for you. Ever since Java 7, you can actually use text strings in your switch statements. A really great trick here is converting your user input to lowercase first, so random capitalization doesn't completely break your match. But, and this is a big warning, if that string is empty, or what we call null, your program will crash hard with a null pointer exception. So always make sure your variables hold actual data before you pass them in. Which brings us to our final topic today. Section 6, controlling flow with the break statement. Now, you might have noticed the word break sitting in that last code snippet. The break statement is basically your designated exit door. The moment Java hits a break command, it immediately stops what it's doing, terminates that entire switch block, and jumps to whatever code comes next in your program. Understanding the mechanics here is absolutely vital. Step 1, the switch evaluates the variable. Step 2, it jumps straight down to the matching case label. Step 3, it executes your code line by line until it hits a break. But Step 4 is the danger zone. If you forget to write that break statement, execution doesn't stop. It automatically falls through and just keeps running the code in the very next case, whether it actually matches or not. Just imagine the disaster. Let's say you write that calendar program and completely forget your break statements. A user types in 8 for August, and your program prints August, September, October, November, and December. It will literally cascade all the way down your code until it finally hits a break or just runs out of block. It's one of the most common and, frankly, hilarious bugs new programmers write. So seriously, remember your exit doors. Always remember to break. We have covered an amazing amount of ground today, from human logic to exact Java implementation. But I want to leave you with this final provocative thought. If you sat down right now to write the code that operates a city traffic light, which structure would you use? Would you build a nested if-then-else chain to check the states, or would you use a switch block for red, yellow, and green? Think about the flow, think about exact matches versus ranges, and think about the readability of your code. Keep exploring, keep questioning, and go have some fun writing dynamic Java code.